Hey, what's up, guys? This is Rudy from Mattiello Consultoria, and this is the master class for the online course Bilingualism, Language and Cognition. This online course is brought to you by Mattiello Consultoria and EDC Rocks. So, here. All right, guys. So, here, as you can see, we have the three modules. If you take a look at the website, you're going to see that we have 4 modules for the online course. But the last module is only projects, the delivery of projects. So we basically have 3 modules. The first module is on brain and language. So let's take a look at what we have here. All right. So in the beginning, we had this idea that we all have a device, an innate device, that is responsible for language, for the construction of grammar. Well, if we consider, for instance, the evolution of electronic devices or devices that we use to listen to music, we're going to see that we started from vinyl records and now we have Spotify. So we had this evolution, the evolution of the devices for music. And if we consider that those devices were only for a specific kind of media, so the vinyl record was only for the albums, and then we had the CD player only for CD or Walkman, which was before. Well, those devices were for specific media. That's what some generativists say about the acquisition of language. We had a device, and this in our brains, it's an innate device, and that device was responsible for the construction of our brain. Well, the argument for that was that one simple exposure was enough for everyone to create complex structures, etc., 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 based on the simple language that caregivers used with kids and the complex languages that we can produce once we're adults. And this concept, this idea, generated a bigger idea, a bigger supposition that we all have the same device. As long as we don't have any neurological condition or neurological impairment, we all have this device. We share this device because this is the byproduct of our evolution. This byproduct is called a universal grammar. This would be like a template in which we inserted certain words and we developed full sentences. Pinker and Bloom had a study supporting this idea, since they studied some people who are deaf and they couldn't communicate orally like we do. So they analyzed the development of sign language, and they realized that some people that didn't have access to a formal sign language, they studied some kids from Nicaragua, and they realized that some of those kids never had access to any kind of sign language. And as they developed their own sign language, their own signs, they also inserted some devices to connect words and develop sentences. So they basically developed grammar. So this is the whole argument, the whole support for generativists, people who support generative grammar, which is not entirely true, since they didn't say whether those kids could hear before or not, because if they could hear before, there's a big chance that they had access to grammar and then they lost the ability to hear, and then they inserted some grammatical features into their sign languages. They forgot to say this, so that's why it's not totally correct. But it's a start, and it's a great study. And then we have another side of the linguistics field, which are those people who claim that the language is cultural heritage. Well, let's start with culture. Culture, according to Feuerstein, is the result of every social interaction. So if a person has social interaction, the result is going to be some sort of culture. And this is a wider idea, a wider concept for cultures, given that, especially here in Brazil, we consider culture certain aspects, not everything that results from social interactions. Well, considering this idea that every social interaction is going to result in some sort of culture, we consider a baby, a newly born, and after 12 months of continuous exposure, this kid is going to start speaking, really speaking. Well, this could be considered, then this speech can be considered a byproduct of culture. This speech is a byproduct of culture, according to this idea of Feuerstein, that social interactions are going to result into some sort of culture. And yes, there's a great support for this, a great argument for this idea, given that or language, complex languages or complex structures, they're not natural. We're going to see in the course and later in this masterclass that a big part of caregivers' interaction with kids are based on very simple constructions. And then later in schools or in life, as we get in touch with certain TV shows or YouTube shows or podcasts, etc., that are more formal, linguistically formal, then we're going to little by little acquire a more complex structure for our languages. All right. And considering that, we tend to mimic what our caregivers are going to tell us. Infants are going to recognize some sound patterns. So from the day that they're born until the first word, they will try to mimic tongue protrusion, and they're going to recognize sound patterns. So that's why we start with very simple linguistic structures as we're babies, because even though we have caregivers making use of very complex linguistic structures, it takes time for babies to recognize some patterns and see where the tip of the tongue must go, etc., etc., etc. So again, they mimic everything, but it's not just a mimic, okay? Not just mimic. Well, of course, after some attempts, they're going to put the phonemes in order. They're going to utter the first word, yes, but it's not just mimicking, okay? It's not just that. And there's a big chance also that babies are going to make use of the word that is frequently used in their daily lives. So according to their social situation, if the word car is frequently used by caregivers, parents, grandparents, I don't know, there's a big chance that this baby's first word is going to be car, all right? But again, it's not going to be just mimicking, Okay, and as you can see on the slide, I used the cat sat on the mat. Why did I use the cat sat on the mat? Because this is an interesting example that Professor Eva Dubrovska uses in one of her studies. Kids, they don't learn the word on. What is the meaning of on? The kids are going to rely on the entire context before they learn the what on means, before they learn the real meaning of on. So they're going to analyze the cat, they're going to see the cat, the image of the cat sitting on the mat. So they're going to realize what cat is. They are going to associate the word cat to the animal, and then the mat to the product where the cat is sitting on, and then sitting, the action of sitting, and then they're going to realize, okay, so what is on? On is probably some sort of positioning thing that is giving me the idea that the cat is on the mat. And this brings me to a very different part of linguistics in the linguistics field that studies the intentions. I have just told you that kids or infants, actually, they mimic the words that are frequent in their social lives. That it's weird to say social lives, but yes, they do have social lives. They're interacting, and they reproduce it. But before that, okay, before that, they're going to point. They're going to point at the food. They're going to point at some objects. So this is this is actually a symbol of how babies can influence our mental state, or the mental state of adults or caregivers. Okay, and then this pointing, this action of pointing, is going to be connected to their first words. Why? Remember, I just told you it takes 12 months for an infant to understand some phonemes and put them in order, etc., etc., etc. Well, this is a process, and the final result of this process is the speech. But before that, we have pointing. Okay, so this is like a pre-verbal communication. All right, and in this pre-verbal communication, there is something really important, which is a shared intention. The kids are going to read the adult's intention. Okay, and this reading of intention is an apparent demonstration of thinking. So the baby is going to analyze the body language of the adult, what the adult is doing, what the adult is saying, phonemes, etc., etc. And this kid is going to understand the entire context in which, for instance, fetch the toy is being used. And then understanding the prepositional aspect of fetch the toy, the kid is going to understand what fetch the toy means. And this is also, as I told you, a process. This is a process that happens not overnight. This is a process that happens all our lives. If we consider the beginning of the beginning of learning of our first language, and the beginning of the learning of our second and third languages. Okay, so this is what happens. So in this process, if you consider our native language, we're going to see that, first of all, a kid is going to understand intention. So we have joint attention shared by a caregiver, normally a mother. I don't want to say mother because we understand that certain kids don't have mothers. They're raised by their dads, or sometimes by their grandparents, etc. So caregivers, all right, guys? So they're going to have this joint attention with their caregivers, and they're going to understand the intention of the adults. Then they're going to recognize the sound patterns, the reference of the words that are being used. And after that, they are going to understand the frequency of this interaction. And after all these things, there's a big chance that this kid, this infant, is going to utter his or her first word. Super cool, isn't it? Super awesome. All right, guys. I don't know if you can see, I don't know if it's clear for you guys, but in this picture we have a tool board, and if you guys could choose a tool to um, hang a painting on the wall, which one would you use? Okay, probably a hammer, considering the tools that are available in the picture. So if we consider that we're going to choose the correct tool for a given, a specific goal, it's the same with our language. All right, guys, it's the same. So let's try to transfer this idea of tool into units, a linguistic unit. So each tool, each word is going to represent a unit. All right, guys. So you can follow me. You can follow me. You can follow me better. Each tool represents a word, just so you can understand. I'm not going to insert idioms. Idioms would represent an entire unit, okay? But each word. In the case of the cat sat on the mat, for example, or fish, the toy. We don't choose the units. We don't choose the tools based on the tool itself. We're not going to choose the hammer because it's a hammer. We choose a hammer because of what we want as a result. What's the result? Hanging a drawing on the wall. It's the same with our linguistic inventory. We don't choose words, idioms, expressions, structures because of the structure per se. We choose based on what they represent, on what is going to be the final linguistic outcome. All right. And this leads us to categorization. So again, if we imagine a toolbox or that tool board that was in the previous slide, we have some wrench, hammer, we might have some saw, screwdrivers, some nails, and some screws, etc. And again, if we want to hang the painting on the wall, we're going to analyze the units or the tools that we have inside the toolbox or on the tool board. And again, what's the target? Hang the painting on the wall. We're going to categorize. Okay, so a wrench, I don't think a wrench is going to be helpful to hang a painting on the wall. I don't think a saw is going to be super useful for hanging a painting on the wall. So this is what we do with our linguistic inventory. We categorize. We think, okay, this structure is not going to serve for a specific purpose. This idiom is not going to fit in this specific purpose. That's exactly what we do in the development of our language. So, for example, we can, as a baby, we can start by using just a specific tool or a specific unit for everything. So let's say that a kid, an infant, has just learned the word horse. So this kid is going to use horse for everything, like horse, by horse, it's horsing, etc., etc., etc. So this kid is going to generalize. This kid is not going to categorize the word horse. The kid is going to think, okay, I can use horse for everything. And well, horsing is not going to fit if I say, if a kid sees a horse running and says, oh, it's horsing. We understand based on the context that the kid is trying to say the horse is running or the horse is really fast or something like this that involves movement, but that's not, that's what happens. The kid hasn't, or the infant hasn't categorized the linguistic repertoire, the linguistic units that he or she has. And for L2, for second language, the path is really similar. And we might think that some people learn better a second language based on the age. Well, that's not true, okay, guys? What is really useful for us to think when it comes to the acquisition of second language is that the more we're exposed to a language, the more we're going to use our higher functions to understand the nuances of that language. And this is going to happen based on how long or based on the length of the exposure that we had through our lifespan, all right? So, but I understand why we started thinking that age is really important in this case. It started, let's try to imagine, for example, a kid, an 8-year-old kid, being exposed continuously to a specific language. This kid is going to design or is going to develop a much richer repertoire than a person that started being exposed at age 28. There's a 20-year span in this case, 20-year. So age of arrival, that's the term that they use, or age of exposure, which is also my favorite expression, better than age of arrival. I prefer age of exposure. Age of exposure is really important because of this, because of the amount of exposure. There's a 20-year span. A kid, a kid that is being exposed continuously from age 8 to age 28 is going to develop a much richer and wider repertoire than a person that started being exposed at age 28. There's a 20-year span in this case. And there's also another factor that contributes, which is length of residence, okay? Length of residence for a person that moved to his homeland to another country. And this is also really, really important. Well, overall, age is not an important issue here, but exposure is really a crucial factor that influences the ultimate attainment of second language. And talking about second language, there are some factors that, as I told you previously, there are some really important factors that influences the native-like end state. All right, guys. We have an initial and an end state. We're going to see this in depth in our course, in the online course Bilingualism, Language and Cognition. But today, we're going to see a little bit of how this works. Well, let's suppose a person that arrived in America at age 12. These are the factors that are going to be crucial in the native-like end state for this person. Pairing of L1 and L2. So we have to be smart enough to understand, to overlap both languages, or the native language and the second, and the additional language, or the second language, third language, etc. We have to be smart enough to overlap these languages and understand the similarities and the differences. If we understand, if we can actually analyze this thoroughly, there's a big chance that we're going to have a very high ultimate, very high end state for a second language, for the learning of second language. Another factor is the use of L2. Imagine a person, this person, 12-year-old kid, teenager, almost teenager, a 12-year-old kid, is going to America, and this kid goes to a community where 90% of those people speak the same language as he does. There's a big chance that this kid is not going to be neither exposed nor have the opportunity to actually produce a lot in the second language, which is, or in the local language, which is English, considering the United States. So this is an important factor that is going to influence the final result, the final outcome, the final linguistic outcome. And the dominance, when I say dominance, is not if the L2 is going to overthrow the L1, but actually, if the person has full control of the new language, the person must have full control of new language, must understand every aspect of the new language, and then master its use. Once the person has mastered the use of this language, there's a big chance that this person is going to have a very high native-like, very high end state, or a native-like end state. Now, if you compare, remember I told you that there's an initial stage and an end state for language, for a second language. Well, yes, if we consider this kid, 12-year-old kid, going to a different country, an English-speaking country, um, the beginning of the learning process of L2 is going to match the final state of L1. Are you following me? I hope so. Okay, guys. So yes. So why am I saying this? Because this kid's L1 is already consolidated. It's already there. And the beginning of L2 matches the end state of L1. So when this kid is going to learn a second language, the native language is going to be the basis for everything. The symmetries and the symmetries, and the representations, the mental representations too. So this kid is going to make every transfer possible from his or her native language to this new language. And even grammar, even grammatical structures. This knowledge is going to come from the native language. Remember, this person is going to overlap the languages. There's going to be some comparisons. And again, the grammaticalization of L2 happens due to this overlap. And if we're not careful enough in thinking and analyzing a second language, we as teachers, okay, there's a big chance that this kid is going to have a strong influence of his or her native language in the production of L2. And if this person insists on using the influence of L1 in the production of English in this case, we're going to see what we call fossilization. Lydia White, in her study of 2003, gave us a fantastic example of a woman actually, that is living in the US, and she's from Turkey. And when she is in a relaxed state, she still uses the numeral 1 in the place of the article or the determiner a. Because in English, we do have this difference. The number 1 and the determiner a. We have the and a in this case, but a in this case. In Portuguese, we also have, we can also use the same word for everything, which is all right? It's the same word for both the determiner and the number. But in English, we do have this difference. And she says, even though this woman has been living in the US for so long, for decades, in a relaxed state, she still uses I have one dog instead of I have a dog. Why is that? Because in Turkish, it's like Portuguese, the same word for the determiner and the number. All right. Some people claim that Our thoughts have a specific language, a specific natural language. All right. Well, let's think the following, okay, guys? Let's think of a car, of a smartphone, an old man sitting on a rocking chair. A polite way to say a t-shirt doesn't fit. So I'm going to repeat, guys. Let's think. You're watching me. Think of a car. Think of a smartphone. Think of an old man sitting on a rocking chair. Think of a polite way to say a t-shirt. A t-shirt doesn't fit. All right. Do you have this in your minds? Yes. All right. Now, guys, I guarantee that when I told you to think of a car, you didn't think of the word car, but you had a mental image of a car, of the vehicle. When I told you to think of a smartphone, there's a big chance, guys, that you thought of a real device and not the word smartphone. When I told you guys to think of an old man sitting on a rocking chair, there's a big chance that you didn't think of the entire sentence. An old man, or the entire phrase actually, an old man sitting on a rocking chair. Well, you can think of me sitting on a rocking chair, an old man sitting on a rocking chair, but you didn't think of the phrase and the units of the phrase. And when I told you guys to think of a polite way to say a t-shirt doesn't fit, there's a big chance that you mixed the combination of words, the structure that you can say, the idioms that you can say, that you can use in a situation, in a context. All right. So this is for you guys to realize that we don't necessarily have a natural language as a thought. We might have some code that is going to support our thought, but there's a big chance that it's not a natural language. Okay, guys. So we don't have an official language per se. We do have some sort of code. Yes, I understand that we might have some code. For instance, binary code. Binary code is some sort of thinking. That's what computers use to think. They use binary code to think and to perform. So this is some sort of thinking, and it's not a natural language. So again, we don't have an official language for our thoughts. What we have are some representations that are stored in our minds, and we use those mental representations to help us think of the language to express the mental representations that we have. Okay? Nice. Now, guys, considering this, what I've just told you, we have to remember we don't have an official language. Yes, we don't. So bilinguals or multilinguals, they don't have like a drawer where they put English knowledge. Okay, so here's a drawer. I'm going to put every knowledge I have of English here. And I'm going to open another drawer and I'm going to put every Portuguese knowledge I have, or whatever is your native language. All right, so that's not exactly how it works. Okay, what we have is what Lee says in his study of 2016. We do have a bilingual mode or an open control state. All right. And when we have this open control state, it means that we interchange some linguistic features of our first language and the second language. So it's out there. We try to get the representations as we have in the picture here. As you can see, we have a brain thinking of poem or palm, and this person has to say apple. And there's the image of the apple, which that's why I chose this picture for this slide. The image of the apple is also part of what we have in our brains. So we have every association happening before before we produce the word apple. This is a bilingual mode. This is what happens. This illustration represents a bilingual mode or an open control state. And based on this open control state, based on this chaotic linguistic happening that we start developing an internal language, or as we say, an interlanguage. All right. Yes, this interlanguage is going to happen based on what we have for our first language, or a consolidated first language or native language, and the linguistic features of this new language. We put them together and we create our internal language. The influences, so actually we transfer the similarities, the differences, we transfer everything. That's why reasoning, understanding, thinking, analyzing the language is also important as students, all right? Because if we analyze, there's a big chance that the interlanguage that we have might transform, might turn itself into something better shaped and not a huge mess. Because chances are that this interlanguage is going to have everything together. The asymmetries, the symmetries, and that's why some of our students say, as Pinker says in his book, the darnest things things that don't make sense, and you as a teacher think, oh my God, this doesn't make sense. Where did this come from? Well, this came from the internal language that our students, that these kids developed based on the consolidated first language, native language, and the learning process of the second language. And as I told you, if we do our jobs correctly, if we're good teachers, if we're great teachers, and I know we're all great teachers, you are great teachers, guys. You're going to do, and you've been doing your jobs amazingly. The internal language is going to become something better shaped. It's going to be more of a language, more something closer to the official language, which is English, and then Portuguese, whether Portuguese is the first language or German is the first language, whatever. There's going to be full control of both languages. And if we have full control of both languages, as a result, this is what we call translanguaging, because then the person is going to choose the best alternative to express the mental representations. All right, guys. So I normally use the example of the music Michelle by the Beatles, because there's a part in the song where Paul uses French. Why is Paul using French in the music Michelle? Well, Michelle is a romantic song, is a ballad, and French is considered the language of love. So in order to represent or to express romance and love, he inserted a French expression. So that's an amazing display of full control of language, which is his first language, his native language, and French, which is his second language, apparently. All right. So this is translanguaging. We should be very careful with translanguaging, not to be a teaching method. Translanguaging is a final outcome. Okay, guys. Now we're about to finish this master class. Okay, guys. Hopefully you're having a great time here with me. When we teach foreign language, we're either creating a new mental representation, or, which is more common, we are making the students access their stored representation and link the already existent representation to this new linguistic feature. All right. So basically, we don't have anything original when we're teaching a new language. There's nothing new. There's there's a big chance that this kid or the students are going to make the link. Why? Because normally the mental representation for the L1 is already there. And that's why I chose this image. I don't know if you're acquainted with the works of Plato, and this is a representation, an illustration of Plato's cave. Plato's cave is this. Communication is, according to Plato, it happens when, as people in a cave, and there are some other people who have access to the outer world. They come into the cave, and they basically show shades, shadows of certain objects. And people who are locked in the cave, all they have access to is the shades that are being displayed to them. So this is pretty much it. So we're basically giving our students the shades of the external world, of the real world, and they are receiving these shades, they are receiving these ideas, and they are going to link to the mental representations, that are already stored in their brains, in their minds, based on DL1. Okay, so bottom line, our thoughts are not just linguistic propositional representations, okay? We're not just teaching a language, all right? We're teaching more than this. All right, and this is something that probably already happened to you guys. When a student says, oh, teacher, what's the Portuguese word for ubiquitous? Or teacher, what's the German word for ubiquitous? What is the Japanese word for ubiquitous? Probably this already happened to you guys. Well, if our thought had a language, a simple definition of ubiquitous would suffice, all right, would be enough. But ubiquitous, it's not, one example is not enough, all right? One example is not enough. We need to make our students have access to what ubiquitous represents, okay? And if our students take our perspective of the word ubiquitous and understand our representation of ubiquitous, and they overlap with what they already have in their minds, then there's going to be the moment, the aha moment, as we say, like, oh, now I understood what ubiquitous is. And that's why they ask us, what's the Portuguese word for ubiquitous? Because in Portuguese, they already have the mental representation, what ubiquitous represents. They already know what it is. They already know what it means. They already have the semantic representation of it. They just haven't realized, they haven't linked the mental representation, the semantic representation to the new word. Okay, all right? Okay, guys, so let's wrap up for this masterclass. So in this masterclass, we talked about some usage-based model and how it fills in the gaps in the beginning of our slide, which is going to be talked about in depth in our online course. We also talked about grammaticalization, how it occurs via frequent exposure, age of arrival, age of exposure, length of residence, which is the module 2. We're going to see everything with more details in our online course. And to finalize, we were talking about thoughts having no language. We don't have an official language. What we have is mental representations, mental images that are linked to some sort of, to a natural language, considering both L1 and L2, but we don't have an official natural language. We do have some sort of, some coding, yes, pictures are a type of language, but we don't have a natural language, an official natural language to represent our thoughts. This is also going to be explored in detail in our bilingualism course, online course, bilingualism, language, and cognition. So guys, I hope you really had a great time with this masterclass. And the online course starts on July 1st. We have 10 spots available, and registration is open. So hurry up, sign up now for this course, okay? Bye-bye.
Hello, folks. This is André Hedlund with the second part of this masterclass for our course Bilingualism, Language and Cognition. So I'm the neuroscience guy. This is my expertise. I'm going to try to connect some of the things that Rodolfo mentioned with this presentation here. So let's start with something that I think is incredibly cool. And it's something that is not very easy to accomplish. Actually, it took a couple of months, more than a year, to be honest. And this is an image that shows how intricate the brain is. So if you look right here, I'm not sure you can see my mouse moving, but let's try to show you the spotlight. Okay, I think now you can probably see my cursor, right? So here we have the filaments that connect the neurons to other neurons. You know, this is somewhere in the brain, one of the folds of the brain. And then here we have the cell body that we know as neuron. This is a brain cell, one type of a brain cell, because we don't have just this one type, we have other types, but we're going to talk much more about this one because this is the one that is really important for learning. So what you can see here, so this is the edge, the limit of our brain. What you can see here is that you have this conglomerate of, billions of neurons that actually join there, and they send signals all over, all the way down to the center of the brain and other areas of the brain. And this was the work of Greg Dunn, who did something that is unprecedented, I think. Joined arts and science to create the most realistic, the most actually accurate image of the brain that we have today. And this was done just a couple of months ago. So this is how the brain is complex. This is incredibly interesting for us to think of the things that we can do with our brains and why our brains are so special when compared to brains of other animals, for example. Did you know that we have 86 billion neurons inside our brains, huh? And those neurons could potentially connect, each one of them could potentially connect to 10,000. Think about that, 86 billion times 10,000. That's math that I can't even do, no, especially because I'm an English teacher. And inside the brain, so I'm going to show you something pretty cool. Inside the brain, each neuron connects through this gap that is known as synapse. So I'm not sure how much you know about basic brain anatomy or neuroanatomy, but the synapse is the most important structure for us to understand how learning happens in the brain. And I'm going to talk about that in module 1. I'm just going to give you some details now. You have to sign up to know the rest. And basically what happens is one neuron has an extremity in which, so if you could see inside this extremity, you would see a lot of little bags, vesicles, where inside of those bags you can find different neurotransmitters or brain chemicals, right? Then an electrical signal travels down the axon, which is that long filament. So if we go back, this is the axon. So imagine that the electrical signal is traveling down or up and down. It depends on the direction of the neuron. And once it reaches this area, it will sort of, move the little bubbles, the little vesicles, and they're going to move down to the wall of this neuron here. So the extremity of this neuron, and they're going to open up and release the neurotransmitters inside of them. And then they are going to travel through this cleft, so this little gap, and they're going to be welcomed by the next neuron, the dendrite of the next neuron. So the dendrite kind of looks like a ramification. It's one of the extremities of the neuron as well, the beginning one, right? And they have receptors that connect with specific neurotransmitters. We have many different types of neurotransmitters. I'm sure you've heard of some. You've probably heard of acetylcholine, dopamine, definitely dopamine, serotonin, oxytocin, and we're not going to discuss many of those. We're probably going to focus more on dopamine, norepinephrine, because they have something to do with the reward system, how we keep motivated and things like that. So this is the process of neurotransmission. It's incredible. That's why I love neuroscience. And if you think about how the brain is divided, so the brain is divided into different areas, different lobes. I'm showing you here a couple of lobes because if you want to know the rest, you have to sign up, remember. So let's start. This is the frontal lobe, the frontal area of the brain, which is responsible for the most sophisticated type of thinking that we can do. So this is what probably, I'd say, this is definitely, not probably, this is definitely what makes us different from animals. So if you look at any other animal's frontal lobe, it's not as developed as ours, and it takes more than 20 years, some would say 30 years, 25 years to develop, because the brain grows from the back to the front, right? And so this is why we can control our emotions more. We can self-regulate, something that animals cannot necessarily do. They act more on instinct, right? This is why we can make decisions. This is why we can organize, prioritize things. This is why we can imagine the future, which animals can't do probably. They cannot go too far in the future as we can. We can think 50 years from now and plan things like that. And then we have this area here. So this is the parietal lobe. The parietal lobe has to do with spatial navigation. It also contains the somatosensory cortex, which has to do with feelings, So if I touch the table, or if I touch a hot cup of coffee, this area is going to be very activated because it's basically telling my body what to feel, what kind of things are against my skin, or things like that. And then you have here the cerebellum. So the cerebellum, this area that lit up before, is also responsible for movement and procedural memory. So the memory that we have for abilities and skills, and for example, I think the most classical example is like riding a bike. So if you did not have the cerebellum, you would not be able to learn how to do anything, not even ride a bike, because you need to make that sort of schema automatic for you to remember how to position yourself on the bike and how to move your legs and arms all together so that you can actually ride the bike. So this is the cerebellum, right? That's why different memories are stored in different parts of the brain. So I can completely lose my speech, for example, or I can forget who I am, forget about my family, but I can keep those procedural memories intact, right? Think about that. I could maybe, if I were a musician, I could actually keep all of the songs that I can play and sing and intact. I could actually keep those memories. But if I had amnesia, some sort of amnesia, I wouldn't be able to remember my mother's name, my wife's name. And there is a guy in the UK, His name is Clive Wearing, and he had exactly that problem. He had a nasty condition, a bacterial infection in the brain, and he lost chunks of his cortex where memories are stored. But he was a musician. He was a maestro, actually. So he doesn't remember who he is, who his wife is, his kids. But if you put him in front of a piano, he can play just as he did when he was, when he didn't have this condition. So the brain is pretty awesome, pretty incredible, but it's still very complex. We're still trying to understand. And there is one internal area here. So you can see this is what we call the subcortical areas because they are below the cortex, and they have a lot to do with emotions, memory as well. So the hippocampus is there, the amygdala, the FFF response center, the flight or fight or freeze response. It's controlled by the amygdala. So we're going to talk about all of that, but we're also going to focus much more on language. So as Rodolfo mentioned, there are two very important areas that are responsible for language in the brain. They're called the Broca's area and Wernicke's area, right? So if you think about Broca's area, it has to do with the mechanics of speech, basically, how you move your mouth and lips and tongue to produce sound in a way that other people can comprehend. If you think about Wernicke's area, it's more about the comprehension of speech, more about selecting the right words that match the things, the mental representations that you want to express. So, and Rodolfo is the expert in this, so he's going to talk to you about Broca's aphasia and Wernicke's aphasia, right? What I'm interested in is they are not the only areas in the brain responsible for language. So if you look at this scheme here, so this is actually an fMRI scan. An fMRI, for those of you who have never heard of, that's a functional magnetic resonance imaging type of exam, right? So you have different areas that activate when you are using language. And these here are not the only areas, depending on what you're doing. So if you are using language and you have this vivid image in your brain of something that you're speaking of, you would see a lot of activation here, even in the back of the brain, in the occipital lobe, because that's more involved with visual processing, for example. And here, as maybe you are familiar with, we have a lot, most of us, to be honest, process language in the left hemisphere. And the areas that are mostly involved, they are, surrounding the temporal lobe, so the left temporal lobe, but not all brains are like that. We have like 25% of brains that actually use the other hemisphere. Yeah, so this is how intricate things are, right? But there are specific areas that match with specific features of the language. So as you can see here, phonology, it stays more here in the temporal lobe, and then here, so this is the parietal lobe, the temporal lobe, and then the junction here with the occipital lobe has to do with lexical semantics, the meaning of the words. So this is where we can find Wernicke's area, right? So it has to do with comprehension, knowing what the words mean and how to match that word to the mental representation to what you want to say, and to make sure that other people understand you, right? And then, so syntax and then sentence comprehension. So they're more here in this frontal lobe area. So language is a wonderful sort of global process in a way, activates a lot of different areas of the brain. And that begs the question, right? Can we talk about localized functions in the brain, or is it more like, hubs of information, kind of like the city of London? So I'm living here in the UK. If you go to the city of London, you will see that the transport map, the tube, like they say here, the underground, you will see that they connect with a lot of other stations, lines, and also many of those stations, they connect with the bus lines. So it's kind of like that if you think about it, how the things are connected in our brain. And so if there's a problem with one of the stations, let's say Victoria Station has a problem, you could still probably go to another station. You could go to King's Cross, St. Pancras, or something like that to get the bus or the train or the tube to arrive at your destination. So it's not just about localized functions, but it's also about the network, okay? Now, then we're going to talk in module 2 basically about language acquisition and how we acquire language, how we learn language. And Rodolfo is, you know, is the guy, he's the expert in this. I'm going to focus much more on some of the theories that are, you know, somewhat accepted by authors around the world. So I'm sure Rodolfo is going to talk about the universal grammar with Noam Chomsky. You know, so he's going to differentiate interactionists, nativists, you know, the ones who believe that we need interaction with other human beings to learn language, the ones who believe that we are born with a certain mechanism or device that allows us to learn language. And there are some who believe it's a mix of both, and then there are other theories. But how do we acquire language? And are there critical periods for language acquisition? Is there something that is more like a critical period or more like a sensitive period? I'm going to focus much more on the work of Patricia Cole, because she, so she has this excellent TED Talk that she basically describes what is the statistical model of learning, which is a theory that babies are exposed to language, so they hear certain words with a certain frequency and certain sounds, especially we're talking much more about phonology here. And because they listen, they hear their parents and whoever is there in your immediate premises, right? Not far away, it has to be there. There has to be interaction in that sense. So they start getting some words and sounds because they can hear them very often. And those words, those sounds that they do not hear, they stop hearing them. So if they are not exposed to those sounds, there might be a gap, there might be a window of opportunity that, you know, after that period, they will not be able to hear those sounds. I mean, that's a little crazy, but if you think about it, I was a subject of an experiment here at the University of Bristol. So my professor played certain sounds from different languages and then asked us to compare. And, you know, some friends from Asia, because it's their native language, they were able to say, no, this is a completely different sound from the second one. For me, they sounded exactly the same. I cannot hear certain Asian sounds because I was not exposed to them as a little baby. And that's what Patricia Cole says. And so there might be a critical period for certain things, but is it more critical or sensitive, right? So if I try to teach myself how to hear those sounds and really practice, would I be able to acquire that? Would I be able to sound like a native Chinese speaker, for example? Is there a window of opportunity, if you think about it? So I wrote something based on the research that I've been doing here at the University of Bristol. And my impression is that for you to learn language, as long as you have your first language, as long as you have that framework set for you, you can learn any language in the world. And honestly, I do not believe that there is a critical period that is somehow biological or maturation of. So it's, you know, that your brain is very plastic at the beginning of life, and then that's the only time that you can learn a language. Because I've seen a lot of cases of people who have started learning a language after the so-called critical periods, because you know what, there are many types of critical periods by different authors and different aspects of the language. So there might be a critical period for phonology, like Patricia Cole says. But what about, if you think about semantics, or, you know, think about being fluent at a language. It doesn't matter if you can speak perfectly like a native, and do we care that much if we can, you know, speak like a native? Is that really fundamental? But anyway, it's another discussion. So I believe that critical periods are much more about phonology and are much more social in a way, if you think about fluency, because they're more like social constraints. Because, you know, there is a time in life that it's really hard for us to engage with language studying, I think. So we don't do it, and that's probably why we don't learn it. It's not because we're too old to learn. And we're going to discuss that and much more, okay? And then there's this incredible tribe in the Amazon that was studied by Everett, and he has a brilliant documentary on YouTube that you can access, and you are going to watch that for our course, that shows some of the outliers. I would call them outliers because they are not, you know, the conventional. If you think about Noam Chomsky's theory about recursiveness and all of that, universal grammar, they do not follow that pattern. So this is a very interesting language. I think one of the most interesting aspects of this language is that they don't really have numerals like we do. So they can subitize. Subitize is something that every animal can do. It is basically knowing the difference between 1 up to maybe 5. You know, between 1 and 5, we can actually tell the difference. After that, it gets too complicated. So, you know, your dog, your cat, or a gorilla, or, you know, a leopard, or whatever animal we're talking about, they can actually tell the difference. If there are 2 preys or 5 preys, they can tell the difference. But if there are 5 and 10, or, you know, 7 and 10, 7 and 15, they don't know really. To them, it doesn't. It's not that different if you think about. For us, because, you know, numerals were socially constructed, we can count, and we have a very sophisticated way of counting, and our maths is something incredible that allows us to calculate, right? So those people from that tribe, they cannot do that as we can. And then, is there a critical period for them to learn that? Can we teach them how to learn numerals, you know, especially the older ones from that tribe? That's a very interesting question, and we're going to discuss that, right? Now, Module 3 is about language and thought. And the biggest question, I think, that we're still discussing, and Rodolfo mentioned that before, do we need language to think? Does thought have a language? Or can we think without language? And what do we mean by language? For example, does your dog think? Does your cat think? Can they think about things? Even though they don't really have language, or do they have language? Do they have some sort of very basic, rudimentary, you know, type of language, and they use that to think? And that brings us to the Sapir-Whorf hypothesis, right? And I like very much this lesson because we called it the 50 Shades of Blue. And I had to mention that, of course, Rodolfo. And the 50 Shades of Blue is a funny reference to 50 Shades of Grey, and also a reference to this hypothesis that has been discussed by many authors, especially Lera Boroditsky. And this is she here. And she has this impressive TED Talk. But let's go back. So here we can see that we have a lot of different shades of blue, right? So this blue is darker than this one, and this one is lighter, and this one is even lighter, and then this one is even darker. Anyway, but what if I did not have those concepts in my mind because I don't have that vocabulary? Think about that. What if I didn't have the words for light and dark in my lexicon? If I didn't have those things in my mind, would I even be able to see the difference between them? Could I actually tell them apart, say that this is lighter and this is darker? And let's go a little further. Are there languages in which there are more words to express the different shades of a certain color? And if those languages actually exist, does that mean that people who speak that language can actually see more shades of the same color compared to us? That's a very cool question, isn't it? So according to Lera Boroditsky, she has a tough name to pronounce. I have to practice. Boroditsky. Yes, we do. We get influenced by the words that we have, the language that we speak, so much that the Russians, for example, they can see more shades of blue because they have more words to express those shades. And there are some people who cannot really see the difference between what is a light color and a dark color. They would just say the same thing because they cannot express that. And because they cannot express that with their language, they can't actually see it. That's very interesting. So it makes us think about the things that we can express with language, because we have language that express that and the other things, right? But the conclusion, to be honest, is that thought doesn't really have a language, because it happens regardless of language most of the time. I wouldn't say most of the time, but it could happen. And because we have language, so thought took over that to be expressed. And that's what made us different from animals, again, is this incredible ability of expressing our thoughts, communicating our thoughts, recording them, going back to them, using them as reference. And that's why we have evolved more than any other animal, right? But you don't need language to think. I'm pretty sure your cat, just like mine in Brazil, we're thinking about something right now, and they don't really have language. We could argue that they don't have language like we do, but they can think about a lot of things. Definitely, they can. I'm pretty sure they're thinking, I'm gonna drop this cup again, or I think I'm just gonna irritate my mom and dad, or something like that, right? So this is module 3, and we are going to wrap up module 3 with the benefits of the bilingual brain. So the bilingual brain is incredibly plastic, more flexible. It can rewire itself better when compared to a monolingual brain. So much that, for example, if we're thinking about neurodegenerative diseases, so dementia and Alzheimer's disease, for example, and you compare the onset, the early symptoms of those terrible diseases, if you take a person who is monolingual and a person who is bilingual, on average, the person who's bilingual is going to display the early symptoms of this disease more than 5 years later compared to the monolingual peer, which means that being bilingual gives your brain some protection, because it's plastic. It's almost like you're exercising the brain, and it's going to be more resistant for a longer time. But that's not all. We can also have improved focus and so attention focus, memory, academic performance, and decision-making skills. And oh, there are so many benefits that you'll have to sign up to know more, okay? And let's wrap up our masterclass. So the very first module we talked about basically ends in this conclusion that the brain is incredibly complex and plastic. It's not about localized functions, it's more about hubs and connections. And we can always learn a language no matter how old. So forget about critical periods. Maybe that's not the way to look at language learning. There are some critical periods that are important, but we are going to discuss them. And finally, our language shapes what we think, even though we don't need language to think. You know, when we have language, because of the words of the concepts of that language, we will be able to see the world in a certain way. That's incredible. So this is the masterclass for the bilingual course that we're offering, Language and Cognition, Rodolfo Mattiello with Mattiello Consultoria, EDC Rocks, and it starts next week, July 1st. So sign up right now. And we're going to discuss a couple of things during the Chá Pedagógico on Sunday. And there's a big surprise for you. So follow us on Instagram, Mattiello Consultoria or EDC Rocks. Thank you, everyone. And we really hope to have you as our students. Bye-bye.